Hi there. Welcome to Mushroom Hour. Today on Mushroom Hour, we're graced by the presence of Tradd Cotter, coming to us from Mushroom Mountain. Tradd is a microbiologist, professional mycologist, and organic gardener who has been tissue culturing, collecting native fungi in the southeast, and cultivating both commercially and experimentally for more than 25 years. In 1996, he founded Mushroom Mountain, which he owns and operates with wife Olga, to explore applications for mushrooms in various industries. And they currently maintain over 200 species of fungi for food production, mycoremediation of environmental pollutants, and natural alternatives to chemical pesticides. His primary interest is in low-tech and no-tech cultivation strategies so that anyone can grow mushrooms on just about anything, anywhere in the world. Mushroom Mountain is currently undergoing an expansion to 42,000 square feet of laboratory and research space near Greenville, South Carolina, to accommodate commercial production and mycoremediation projects. His masterwork and the must-own mycology reference, Organic Mushroom Farming and Mycoremediation, had a huge impact on my own relationship with mycology. So Tradd, thank you so much for coming on the show.
Thank you for having me on here. We look forward to talking and entertaining everybody at the same time.
That's the best we can hope for.
Yeah.
It's a little bit of edutainment. Well,
what do you want to talk about?
I want to talk about it all, and someone like you has a million things going on. You know, I know the biographical story might be a little bit of an old hat for you, but tell us a little bit of how you got into mushrooms, just that brief synopsis.
You know, I was interested in nature when I was young. And when I was in college, I was 18, 19 years old. And I was interested in going into like the medical field. But one day my mom came home and said, you know, there's a medicinal mushroom farm out on Johns Island, South Carolina. And she goes, you should go tour it. And I said, okay. That's when she found out I was growing mushrooms in the attic.
Oh.
And I told her I was growing portobellos, but I wasn't.
Of course you were. Yeah.
But she knew I was interested in it. And I went out there and went on a tour, and I was hired on the spot. So, you know, I started putting a lot more energy into my fascination with fungi. I started picking up lab equipment, tissue culture, started mushroom hunting. And, you know, I was on my own. Back then, you know, the internet was just a child. There was very few references or ways of identifying mushrooms. So I went out, started identifying wild mushrooms on my own, and then I started cloning them. That was probably the turning point that fueled the fire, was that I started to wonder, like, well, we only grow 2 types of mushrooms at the farm. Right. You know, what about all these other ones, you know, that are good, they're plentiful, they're in demand, they're seasonal. So I started culturing things like maitake back when people were not growing maitake indoors. I knew I could do it. I had that curiosity. And after a year and a half, 2 years at that mushroom farm, I left and I started Mushroom Mountain in 1996. You know, so I've been growing mushrooms and this is my life's work. I love it. You know, there's nothing I'd rather do than wake up and just think about mushrooms all the time. You know, it's like during the day and at night, I'm dreaming about them and coming up with potential solutions. You know, that's where I'm at now. It's so much beyond just the cultivation. It's what can mushrooms do, you know? And yeah, we've got 200 species. We probably have more like 300 species in the lab now.
Wow.
And, you know, there's thousands of species in this area in South Carolina. So I don't feel like I'm ever going to run out of things to do. It's crazy. Right. And I love encouraging others to do the same, because we all need to work on what mushrooms can do.
You know, it's going to take all of us getting involved to explore all the possible solutions when you're talking, you know, estimates ranging from hundreds of thousands to millions of species of fungi. The only way we're going to explore it all is everyone getting involved. And that's something I've often thought of. Are there mushrooms out there, you think, that have medicinal properties locked away, have some mycoremediative property locked away, and we just don't know it? It's not one of like the big cultivated mushrooms. It's not one of the most well-known ones. It just has properties waiting to be unlocked, even something poisonous or something like that.
Totally. And we have poisonous and deadly species in our collection. People are like, why do you have those? You know,
right.
Like
question your motivation.
Like a government watch list or something. Going to turn to the dark side. But no, and the answer to that question is every single fungus. And when people think of, you know, this is the mushroom hour, but fungus that's a mold. That could be a yeast.
Yeah.
It could be a mycorrhizal fungus. It could be an endophyte. It can be anything. So I don't feel like there's no way it's going to ever be fully explored. I just think there's an infinite number of potential for those millions of fungi that are here that we haven't discovered yet. You know, when they say, well, roughly 160,000 fungi have been discovered, DNA sequenced, and they estimate 5 million out there still waiting to be found. We haven't even tested every single one that we found for medicinal properties or for remediation of building materials, anything like that. If you're a math major and you do all the variables and then you factor in 5 million, I mean, it's going to go on forever. You know, it's not, oh, we're going to accomplish this in our generation, our lifetime. No, this is for the long haul in humanity, you know, in civilization. It's just going to constantly work on.
And when you bring up numbers like that and the incredible amounts of solutions hidden in so many different kinds of organisms, you can't really overstate it that it is kind of the future of humanity. I mean, further exploring what these life forms have to offer is generations and generations of work. And you're always left feeling there's so much hope there. Mm-hmm. You know, we're faced with a lot of problems, but there's so much hope. There's 5 million nth to the whatever amount of solutions locked away in those 5 million species.
And that's what gets me up in the morning. That's what gets excited. You know, we just had a meeting with someone we just hired, and I could see the passion and excitement in their eyes. And that gets me fueled, because it's not just someone who wants to work with us. You could tell they have that spark, you know, they have that flame. That's the kind of person people we like to bring in the door, is to be a part of this dream team. And we keep layering, you know, employees. 5 years ago, we had 1 employee, and now we've got 8. And I told this to Clemson University, the business school came and interviewed me, and they're like, how do you success? You know, what makes you happy? And I said, every other Friday when I sign paychecks. We're responsible for people's livelihoods, you know, ultimately our team. But at the same time, it's my first employee buying her first house, you know, and, you know, things like that. It means a lot to me. It's the humanity of owning the business too, that we're able to put people to work, but we're also able to attract people that share our vision and want to contribute to that. And they want to see things realized. We're working on so many things. Some of them are very complex and could be disruptive. You know, that's some of the things we'll talk about. That's what I want the legacy of the company to be, you know, not me.
Right.
I mean, don't give me credit for this. Give the credit to the fungi. You know, you got to stay humble in this and say, yeah, I mean, this is what I do. I'm curious, but I'm learning what the fungi are teaching me to develop solutions. They're the ones that have the actual gift. I'm just putting them in the position to help human civilization.
Listening, trying to find new uses. And there's something special about that collective effervescence when you're really turned on about something with someone else and you guys are really activated and you're able to share in that and build something together like what you guys are building there. Mm-hmm. That's really something special. I guess Mushroom Mountain started as really all about the cultivation, I'm guessing for kind of food and medicinal use, but just give us the overview of what are all the different things you guys have your mycelial hyphae in now. You know, what are all the projects that you guys are working on?
I just talked about that with the new hire. You know, Mushroom Mountain is essentially a holding company, and we have different pillars of businesses or concepts. And so there's the farm and the spawn laboratory. That's one pillar and its own entity. The other one is a medical entity, which includes mushroom extracts, antibiotics, things like that. There's mycoremediation, which we work with a friend of ours, Leif Olson. Leif's amazing. So remediation of toxic soil and pollutants. We're working on mycofiltration projects. So we can take bacteria out of water, which could be huge for like Haiti and Yemen. And there's so many different layers to the business that we're adding, different products, you know, research and development. We're just trying to figure out how can mushrooms help us. That's what I think about when I wake up. It's like, let's do this.
And that's some of the most inspirational material that I've heard you talk about, you know, in various YouTube videos and all the stuff you put out there, is talking about how growing mushrooms can be really impactful to underdeveloped countries, both as a food source, as a medicinal source, but also as, you know, a mycofiltration system potentially for a village that grows food. You know, what are some of the applications of mushroom technology, mycotechnology, if you will, in the developing world.
Actually, I was just on the phone with a food writer from the Caribbean who called me about a mushroom that grows in Haiti. And after we got done with that, I told her about what I was doing down there. And, listen, I said, mushrooms are high protein, vitamin D, good meat substitute, can be grown on just about anything, oyster mushrooms. A system that we developed for the earthquake in Haiti, we called it the Mushroom Rescue Modules. It's in my book. And it's an idea that people can take debris, agriculture, or even, waste, or cardboard, paper, anything, stuff it into these containers and grow mushrooms with a starter culture and have edible food for their family in just a few weeks. And then that can perpetuate. You could take that bin and share it or expand it tenfold every week. What's also sexy about that idea is that you could filter water through the media when the mushrooms are done fruiting.
Right.
So you have the system of fruiting mushrooms, the old bins, you filter water, take out bacterial pathogens. Number 3, the same bins will produce octanol. Mushrooms produce a chemoattractant that attracts mosquitoes. So you set up the bin somewhere where it vectors female disease carrying mosquitoes where they can be trapped. So you can keep them away from human populations at night. So that's 3.
Wow.
Number 4, you can use the media and mix it with clay and develop a carbon negative building material, which is also what we're working on. It's a myceliated clay. So you mix it with the clay, form the bricks, and then it's like chemical rebar. So there's 4 very important things. You're talking about food, water, and shelter. All 3. Right?
I mean, that's absolutely mind-blowing. And how close are we to any kind of institutional adoption? Because I'm sure listeners, like I'm having a reaction like, that just makes all the sense in the world. Mm-hmm. Whenever we're trying to help a place that's been struck by any kind of disaster, whether it's, a tsunami, whatever it may be, it would seem like obvious to deploy something like that that meets all these basic needs just with mushroom mycelium. So have you guys taken that route at all, working with, disaster response institutions, or is it more grassroots putting the schematics out there to let people do it in those areas? Or?
Yeah, I mean, we're talking to a lot of people right now. There's people, you can look up the Mauritius oil spill. I don't know if you heard about that.
No.
Look that up if you're listening. It's a disaster. It's beyond a disaster. It's actually heartbreaking. I think about it a lot, and I get emotionally affected because I think about if I was an indigenous person on that island and an oil tanker struck the reef and broke in half. The damn thing broke in half. And it's a very delicate ecosystem, and just thousands and thousands of tons of oil hit the shore. It's terrible. So they contacted us to see if we could put together an idea for a mycoremediation project. That was just, the oil spill happened, I believe, in June or July. The thing broke apart in August. So we're trying to work with the Wildlife Federation over there. They're in the process of putting me together with the United Nations for food security there. Because I told them, I said, listen, we're going to need biomass to do the remediation, meaning we're going to need, spent oyster mushroom substrate to help with the remediation. It makes perfect sense that we teach mushroom cultivation workshops. So number 1, people have jobs, they have food. The fishermen are out of jobs. So now they can, at least until the ecosystem recovers, putting them in a position to generate food and income for themselves, for other families. Instead of selling fish, they sell mushrooms. Right. And at the same time, you have this community effort. It's not us coming to the rescue. It's them helping themselves, so it empowers the community. We just have to show them how to do it. That's on the hot button right now. You have to be. And it's an opportunity to get boots on the ground and prove and disprove that things work. I mean, otherwise it's just another chapter in a book that says you could do this. Mushrooms can, they may, but that's just not good enough. I'm ready for action. I'm ready for these things to be deployed into refugee camps. I lived over in the Middle East. I've seen refugee camps in Haiti, and I just want mushrooms to be a part of the solution. It's a work in progress. Yeah, totally.
I mean, taking it from the theoretical and putting it into action, how powerful is that? And I think a lot of us are hungry for that when you get into this world of mycology and you start learning all these amazing things, reading your book, reading a mycelium running, whatever it is, you start thinking, man, why are we not doing this already? Mm-hmm. So it's really cool to hear that you're actually taking those steps to start the implementation phase, which is, where you run into those difficulties, what works, what doesn't. In a general sense, just because mycoremediation is something so many of us are interested in, it's one of those big, hope inspiring aspects of working with mushrooms. What's kind of that general concept of mycoremediation? Because when I was reading some of the material you have, it talks about, land enhancement, mycoremediation. So when we're talking mycoremediation, what are we really doing? And what are some of the ways that we actually deploy mushrooms to solve environmental problems?
Right. And fungi can naturally figure it out. There's indigenous fungi. And that's what I said at the beginning. Don't discount all those organisms in the soil. Most of them are molds. They're ascomycetes. The
Right.
bulk of all fungi, that's why they're not discovered. It's because who has time to scoop up a gram of soil, streak it, and now you got, 100 new species, DNA sequencing and everything. People have put way too much attention, including myself, on mushrooms that you could see because people identify with that. They sometimes think, well, the molds I don't see them, nothing's happening. So I'm really anxious to start testing molds, and going to these disaster sites would be a great idea because to me, it's a build it and they will come approach.
Mm.
And the Mauritius government was talking about this, that of course, I agree with this. I mean, they don't want us to bring fungi from another continent there. That's an island. That would be biologically dangerous to the ecosystem. So what we're going to do is ask the community to go out and look for mushrooms that are growing in and around the devastated environment. So those organisms would amplify and show up. What kind of happened was that oil spill put out a welcome mat and is selecting fungi and bacteria and different organisms to thrive in that devastated environment. So that's one of the tactics that people really need to think about, is not saying, oh, well, this oyster mushroom, it can break down oil, so I'm going to bring it over and I'm going to use it.
Yeah.
Well, it's a strain from North America, number one. It's not going to like the climate. Find something there. And that's number one, is really discovering the fungus that can do the job first. There will always be a better fungus. Don't delay. We can't be afraid to fail. We got to go fail forward and keep trying and figuring out these fungi. The good news is those players on the field are already out there and running tests. You don't be afraid to do a pilot, do a countertop test. We've done so many of them. And right now we're doing filtration studies for the city of Greenville, which is my neighboring city. And they're taking a huge leap of faith that there hasn't been many microfiltration projects documented in the world. It's all on paper. It's all theoretical.
Right.
Or hypothetical, rather. And so we're taking this step, and, Mushroom Mountain is meeting halfway or more than halfway on developing the system. It's a huge cost. Research is not cheap. And we're willing to put our chips on the table, get some skin in the game and say, let's try this. Let's try a couple different species. Let's try a couple different media formulas. Let's run bacteria through there and let's see what happens. If it doesn't work, try it again. If it doesn't work, try it again. Will it work? I'm an optimist, unfortunately, and I don't give up.
Well, that's what we're going to need. I mean, anyone who's tried to cultivate mushrooms knows that mentality is definitely necessary just to get mushrooms to grow successfully, much less when you're talking about implementing it on a bigger project. And you got to the heart of what was going to be my next question, was like, it's amazing to see, mushrooms being used as tools in disaster areas or underdeveloped areas. But what are some ways that we could use it in our own infrastructure here in the US? What are some of the ways that we could use it right here at home? And that one's really inspiring. Mycofiltration. Just to get to the nuts and bolts a little bit, is that just as simple as running water through a mycelial mat? Is there any special consideration of substrate, or how does that work?
Yeah, it's not that simple. And I appreciate, everyone's effort and excitement. But when I see mycofiltration studies or a installation done, you see them all the time online. There's just putting mycelium in wood chips and burlap bags and throwing them out in the environment. And there has to be some preliminary testing done first. Number one is, species selection. What we did that no one else did first, I believe, is that we tested the fungi for tensile strength. And what that is the ability for the fungus to bind the particles together, right?
Right.
I mean, what good is a fungus? It could be really good at remediation, but it could be a weak binder. So if you put wood chips out there and you mix it with the mycelium and you have a rain event, it would just blow the filter apart, right?
Right.
So we looked at high tensile strength, also the ability to cross wall. And I know nobody can see me, but if you take your fingers and put them together and clasp them together, you're making surface area. And you want a lot of cross walling because you want bacteria to get trapped in there. I'm talking about bacteria. I'll talk about chemicals in a minute. Bacteria are easy if you understand that you need cross walling. So the particle size of the substrate is important. Let's say everyone visualize a bunch of big wood chips, big chunky wood chips. Well, the water flows right through it. The mycelium is not going to make that tight knit in those big gaps, right? It's just going to stick to the wood chips.
Right.
So you have to design a media where water flows through it, which is tricky, at a high rate of flow that cross walls heavy and doesn't fall apart. So there's more to just throwing it together. And, we've developed formula after formula, and we finally got one that seems to be working. And we use a fungus that my mom found down in Key West, Florida.
Oh, that's amazing.
And it was really cool. She called me and said, I found this mushroom growing on a Australian pine stump in Key West Harbor, right at the edge of the harbor, meaning she said the waves were lapping over the top of this stump and there was mushrooms growing off of that. Well, if that doesn't turn you on as a mycologist, and I'll tell you why. I know it's sad to say it turns me on, but it does. This is why it turns
Just being
me on.
honest. Yeah.
Yeah. It's growing on Australian pine. It's a tree that is really hard to break down. So that tells me something, that fungus has chemical keys or enzymes that are special, and it can break down this tree. So it's got a very strong key set, which means it might be able to do wonderful things to very difficult to decompose or break down molecular stuff, nasty man-made pollutants. And number two was that salt tolerance. Oh my God, that's huge. Let's talk about that Mauritius oil spill right now. It's not in fresh water. You can't use an oyster mushroom because it's not gonna vibe out with that salinity at all. It's not gonna grow. It's gonna die. So
of course, yeah.
So here you have it. The tensile strength of the tiger sawgill we tested at Columbia University on these little bricks that we made, and in pure block form, like pure mycelium. King Stropharia, by example. A lot of people might know that mushroom, little garden giant.
Yep.
That's been used in remediation. It started it all. It's like, oh, well, this one can filter bacteria and all this stuff. It's terrible. It's actually the worst one. And I'll tell you why. Because, well, it has a tensile strength of 30,000 times its own weight. That sounds great. All right. Here's why it's not great. Once it gets into the environment, in the lab, it's cross-walled. It's really tight and thick. It's cottony. But once it gets into the environment and it gets exposed to bacteria and the elements, it gets really ropey, and it's like Swiss cheese. So it really does not make a good filter. And they've actually seen bacterial populations spike because there's so much organic material and not that much mycelium there. So it feeds the bacteria and it amplifies it. All right. So that's strike number two. Tensile strength, 30,000 times its weight. So let's go back to the tiger sawgill mushroom. That one forms tight cross walls. It grows kind of like an oyster mushroom. It's tight. And it has a tensile strength of 800,000 to 1 million times its own weight.
That seems astronomical. I don't have a basis of comparison, but that seems absolutely amazing.
It's like if you twist it into the same diameter as a thread of steel.
Yeah.
Right? That's the comparison. It could be as strong as steel, and it's a living strand of cells, right? That's what's incredible. And that's the fungus we're using in the clay with the building materials. I owe a great gratitude and credit for my mom.
Yeah.
Finding that she could have revolutionized building materials and all filtration and all kinds of things. And you know what? She was just walking along the beach, which should tell anybody listening, whether you're a mycologist or not, that when you notice a mushroom doing something that just looks a little off or different, collect it, dry it, and send it to me. Got to send it to me. And that's the community approach, is that I'm not out there collecting so much anymore, but if there's more people who care about the planet and they know that fungi can do these amazing things, they're going to be on the lookout. We'll get these things turned in. We'll test them. We'll see what we can do once we get them.
Yeah, and it's an amazing story of just observing, listening to the mushrooms, listening to nature. And what's something that really struck me that was actually in your book is this idea of thinking like a mushroom. Maybe not exactly thinking like a mushroom, because I don't know if we can enter that crazy headspace, but just understanding what that mushroom is as an organism and what it's doing. So when you see it growing on a novel substrate, you know, okay, there's some weird enzymes being produced here. There's something going on here. One of the other areas of your work that really ran away with my imagination was your work in the medical field. Makes sense that was kind of what you were interested in before you got into mushroom cultivation. But I know you've given some talks about how mushrooms might be able to change antibiotics and change medicine. What are some of the uses you guys are working on there for mushrooms in the medicinal arena?
First, I want to start by beginning, that I said every mushroom is medicinal, and it sounds like a profound statement, but it's true. They're out there battling their way. There's a lot of competition in the wild, and they have to defend themselves, and they have to do what's called nutrient capture, and they have to fight for territory, just like humans do, because they want the resources. Right. And they'll battle each other too. The mushrooms don't like each other. I hate to say that to everybody. It's kind of sad, but
we like to think they're all holding hands, singing Kumbaya, but they're competing.
Rainbows, Care Bears, everything. No, it's not like that. If it's clonal, a shiitake strain in the lab will fuse and it's friends, but even two different shiitake strains will try to kill each other in the lab. They don't like each other,
Right.
It's like people, it's competition. So they sweat out all these biological weapons in the form of antibiotics and compounds to defend themselves, but also to surface disinfect where they're going. So if you're listening to this, you can imagine this fungus, these threads are dividing and penetrating the wood chips, let's say, or a log, and it's not sterile. And in front of it, it's actually sweating like a little bead of moisture. And it's drilling and swimming through that bead. Now, that's where the magic happens. It's because the tips of those hyphae are very intelligent, chemically intelligent, and they're detecting what the nutrient source is. They're sweating out the enzymes to eat it, and it's dynamic because at the same time, if there's another fungus or a bacteria there, it's in the way. It's going to sweat out